All right, so with the equations we just solved in the previous video, I did convert all of those E answers and natural log answers into decimals. And I think our Desmos scientific, it's easier because of like nested fraction thingies, you know what I mean? So it's easier to type in, if you have something like what I have here in Desmos, because of that nice fraction key. So if you hit the fraction key first, let me go to main, and then you have, say, natural log, you go to function, natural log's here. So maybe you're up here and you have natural log. Well, maybe natural log, and then maybe you have, say, I don't know, 12. And then let's do end of parentheses. And then you maybe have minus, come up here, we can do it. Minus, oh, it doesn't like me today. Let's go up. Come on, you can do this. Minus, can we hit minus? Evidently not. Can we hit plus? There we go. We'll do plus then. And then again, natural log of, say, I don't know, maybe 2, and then down here, and then it's just easier to type in. All right, I think so, if it lets you. Something weird's going on with mine, but probably because it's highlighted. Yeah. So, and then maybe natural log of 2 or something like that. Don't highlight. There you go. And it'll give you the answer. You just have to be a little careful on a TI. All right. What I want to do is, let me go back to these. So what I did is I converted all of the answers we just got into, if they were like this, decimal approximation. All right. And I want to look at all of these graphs. So we solved 5 equations, but I'm going to graph these. So I'm going to graph all 5 of them so we can kind of see where we're at. All right, so let's look at equation 1. And this is just a good way for you to check your answer. You need to be able to do the algebra, but the first one, we got x equals 10 when we did algebra. And then the second one, we got what, 8 and a -2. Okay, so let's go on to Desmos and look at those two. All right, so I want Desmos graphing. Okay, so let me go to the beginning. We got to hide some stuff because I have them all typed in here. Oh, one more. All right, we're going to hide those. Okay, so the first one, I'm going to graph the left and the right to see. Okay, and we got an answer of 10. All right, so I kind of know what to expect, right? So I'm going to zoom in at 10 and see. Yep, there we go. So at 10, it works. That's where those two functions cross. They both give an output of 1.477, but I just care about the x value, okay? So I can check my answer, okay? And they don't cross anywhere else. Okay, I'm gonna get rid of those two. The next one was this one. So again, I like to graph the left and the right. All right, so if I look at this one, we got an answer of what, 8, which again, sometimes you have to pull on both functions to get it to match or whatever, but there's the answer. So 8 gives you an output of 2, which is what we want. But notice over here, because exponential can have negatives, logs can't. But again, you might have to pull to get it to, oopsie, match, but where's that? Right there. There's my other one. And so 2 and a -2 are the answers for that. And again, I can check that. All right, the next one was what, a double log. Okay, and this one we got some ugly, kind of log answer. But remember, logs are decimals, it's fine. All right, so if I pull on the red and kind of come in here and pull on the blue and kind of come over here, right? This is where they cross. And if you, that is the decimal approximation I got. So if I go back to here, all right, you can see I typed this in decimal scientific, I got that decimal, and that is where they cross, okay? The fourth equation we did, we got an answer like this. And again, remember, E is a number, right? Just like pi is numbers. And so I typed this into decimals, I got that. So to check my answer, I am going to go back to Desmos. All right, so I'm going to get rid of those two. And this is the left, and that is the right of that one. All right, so let's go back to where we were. Okay, and let's go. And again, if you do the blue and then you do the green, right, it'll do that. And that is 2.367. That's exactly what I got when I did it with algebra. And then I'm going to double check my last equation, which was this one. And this one, we had that, that complex fraction with all those ln things in it. All right, so, and again, I'm only expecting it to cross once, which that's what I'm seeing. So kind of zoom in there, right? Right there. And I got 0.146, which again, I am going to get out of here. And on this last one, I typed this into decimals just when I started the video. That's exactly the decimal I got. Okay, so now we're going to use a lump sum formula. You're going to invest $10,000, 1 plus the interest rate in decimal form, move it 2 jumps, so 0.055 weekly. So your N is 52. If it was monthly, you'd use 12. Daily, you'd use 365. And then your exponent is N times T. So you're going to take weekly. So you're going to take 52, which is how many weeks are in a year, times what, 40 years. And then we get that exponent of, can we see it? Maybe, there we go, 2080. All right. And then I'm just going to type this in decimals just because it actually is a little easier. But if you're going to use a TI, just use lots of parentheses and order of operations. But decimals will do it for you. So $90,145 and about 27 cents is going to be kind of where you're at there. All right, and then the next one is using that kind of PERT formula. Let's see, this one is continuously compounding. All right, so, and they're telling you that it's going to grow to 25,000. All right, so you have 25,000 as the output, the amount of money with interest. You're investing 5,000, that's your principal. E is the Euler's number that occurs a lot in just real life and nature. Your rate is 0.06 and your time is t, and you don't know it. So again, to solve any equation, you isolate the function. There's your function. So I divided both sides. I got that. Now that it's isolated, how do you undo exponential? You go to a log, right? So logs eat answers. They spit out the exponent. So this is your answer. The log's going to eat the answer and spit out the exponent. Divide by 0.06 on both sides, and you're going to get the time. And I got that time right there. And again, I can either type this on a TI. The only thing you have to be careful on this is if you have natural log, and again, the angle is kind of hard to see. If I have natural log of 5, make sure you have an end parenthesis. And I would probably even maybe hit enter and then divide by the 0.06. Right there. But again, decimals, you can use that fraction, so it's a little prettier. All right, I'm going to pause here and we'll continue. Okay, this type of problem will be extra credit on the test. All right, now I'm going to give you the formula. It's kind of hard to see there, but that is raised to the negative KT. Newton's law has a negative because it's decaying. It's going down, right? Things are cooling, right? You take a hot cup of coffee, you sit on the counter for 2 hours. It's going to, you know what I mean? It's not going to be hot, burning hot when you go to it. All right, so here's the formula. This is the start, like the room temperature. That's your starting temperature, room temperature, or the environment. And then E, and then that's to the negative KT. So what's going to happen on these is, first of all, they are going to give you enough information to find the constant, okay? So just don't read the questions. Let's just see what they gave us. They gave us that, it started out at 550 degrees. That's the starting temperature of the pizza, right? Room temperature is 70. So there's 70 there, 70 there, okay? That's your room temp, okay? Or your environment, whatever. E, you don't know K, but it's 5 minutes passes. So you're going to put a 5 there. And you do know after 5 minutes that it's 300 degrees. So you know the output, right? Your input is a really hot pizza pan, and then you have the environment affecting it, but then you also have output. All right, so again, how do you solve equations? First, you isolate the chunk. You got to get rid of the 70. So I subtracted and got 230. Then you have to isolate the function. So that's when I divided. Okay, and you really don't have to reduce here because you're going to use a calculator anyway. So if you just want to leave it like that, you're fine. All right, now this is isolated. How do you get rid of exponential? You go to logs. Logs eat answers. And again, whether you cancel them or not, doesn't matter. Logs eat the answer, spit out the exponent. Okay, and it's natural log because I'm in base E. Okay, now I want to do this. See how this became linear? You know what I mean? We had to use exponentials and logs, but eventually this is just linear. This is a number equal to a negative 5K. So divide both sides by negative 5. Again, I use decimals on this, but you can use a TI. I would just put that in parentheses, hit enter, then divide by negative 5. So this is my K. Okay, so this is my constant of how this thing is cooling. Okay, now we're going to use it to solve questions. Okay, so let's look at A. When is it going to be 135? Okay, again, this is room temp, this is what it came out of the oven. Now I want to know, when is it going to be 135? Now they're asking me for time, but see, now I know my constant, right? I know that there's a negative point, and that's my constant times time. So my goal is to solve for time. Again, how do you solve equations? Okay. First of all, you want to isolate the chunk. So subtract to get rid of the 70. And we know this is 380, same as over here. Now you want to isolate the function, divide by 380. And again, doesn't matter if you simplify. Okay, because these are going to cancel. Now, again, you have exponential. You want to use a log because you want to solve for time. So logs eat the answer, spit out the exponent. Divide both sides and you get a time. Now it's about 17.6 hours later. All right, and then if it's about 17.6 or 18 hours later, if you're not good with adding time, what you could do is take that 18 hours and say, okay, it's going to take 7 hours to get to midnight, right? And then I'd have another 11 hours after that. So that's, you know, kind of where that 11 a.m. comes in. I started to do kind of some military time, but I don't know if people like that. So, all right, next one, determine when it's going to be 160. Same thing, output, room temp, how did it start out at? We know our constant. Again, isolate your function, bring that over, divide, logs eat answers, spit out exponents, divide. I ended up getting this. All right, last question here. What do you notice about the temperature as time passes? Okay, so this was what? After 14 hours, it was about what? 160. And then after 17.6 hours was at 135. So if you've ever drank a hot beverage like coffee or you had soup or whatever, you know, over time, it is going to have the limit of going to room temperature, right? So eventually this thing, right, is going to go closer. Your output is going to get closer and closer. The more time that goes by, it is going to have a limit, and it's going to go towards the 70 degrees. Okay. You let pizza sit out on the counter for all day long. Eventually that pizza is going to be room temperature. Okay. Whatever your room temperature might be. Okay. So, and again, that's like a limit. As the time goes off to infinity, what's happening to the temperature in Newton's law? It is eventually going to go towards room temperature. All right. Okay, I'm going to stop here and then I'll do the last part of the review.